Welcome.
Hello. Yeah.
Chapter 7. A whole chapter about lines.
Yay.
Get excited. Come on. Yeah, come on. That is pretty lame. Yeah, a whole chapter about lines. Who would have thought that's even possible? Yep, it is. So while it may not seem thrilling at first, there are lots of things I guess you can learn about lines. Even though this, whoops, that's not a line. This isn't very exciting. When it's put on a Cartesian plane, there is quite a bit of information that you can interpret from that line. Looks really plain, I know. Don't worry, you'll all be super excited by the end of the lesson. I'll barely be able to calm you down, I'm sure. Okay?
Yeah.
Lines model linear relations. You should know that by now. Linear relations, when you graph them, are lines. Okay. Some of the situations that can be modeled with a linear relation, at this point, they're pretty simple situations. Things like how fast an object is moving at a particular moment in time. Right? You know that as speed. So that'd be like a distance versus time graph for something that's moving at a constant speed. If somebody's saving money, so they stick X number of dollars in their mattress every month because they don't trust the banks, or they're just weird. Sorry, I shouldn't say that. If you have grandparents who do that, then... Does anybody have grandparents who does that? Okay, so it's weird if you stick money in your mattress. But you can model how your money is growing month by month every time you stick money into your mattress using a linear relation and therefore a line. The price of your cell phone bill, if you get charged for going over your minutes or going over your data, that is a linear relation, thankfully, because if it was anything else, except a radical relation, you would pay lots of money. What does that mean? You'll get the joke in a few years, I promise. The rate of temperature change over a small time period, for instance, from morning to afternoon, the temperature could go up, right? If you're talking about an entire month or even an entire day, the temperature tends to fluctuate, but there's straight portions of that graph. So if you're talking about a relatively short period of time, the relationship is usually linear, usually. And also the volume of a tank, if you're filling it with water or grain or jelly beans or bunnies, okay? You can model how the volume of that tank is changing as you're filling it up or emptying it, okay? So, there are 3 ways to write the equation of a line. Baffling, I know. 3 ways. Okay? Each form of the equation tells you something different about the line and is used in different circumstances. Okay? The first way you're going to be learning about today is called slope-intercept form. Okay? Yay!
Yeah.
It looks like this. Y equals mx plus b. Okay? This is an equation in slope-intercept form. And it tells you 2 key pieces of information about that line. And those pieces of information you can determine just from looking at the equation. Anybody want to guess what the 2 things we can tell about the line are, just straight from the equation?
Dependent variable.
Here's a hint. It's in the name.
Slope.
You can tell it's slope. You could also tell
Intercept.
specifically the y-intercept. Okay? So slope-intercept form tells you the slope and the y-intercept of that line. Here's how. Okay? Oh, those are those 2 pieces of information in your number 1, number 2. Number 1, slope. Number 2, y-intercept. Okay, those are the 2 key pieces of information that you can tell. And quite honestly, this is one of the more popular forms of the equation of a line. One that you'll see again and again later on in grade 11, grade 12 math and beyond. There's another form called standard form, which you also see every now and then, but Slope-intercept formula is pretty popular. So how do you tell what the slope and the y-intercept is?
Guessing.
Okay, looking just at the equation. Well, remember that letter M? Where else have you seen that? The letter M. Yeah, you've seen this formula before, right? M equals y2 minus y1 over x2 minus x1. You guys remember that?
Oh, yeah.
That tells you the slope of a line. Okay? This M, I don't know why they chose M for slope, but they did,
That's weird.
means the same thing as this M. Right? So when you're looking at the equation of a line, whatever number is in front of x, when it's in slope-intercept form, is the slope of that line. You don't have to calculate it. You don't have to take 2 points and put it in a formula. You don't have to do rise over run. You can just look in front of x. Boom. Amazing. Okay? That's the slope of the line. The y-intercept is this value b. Why they chose to use b to represent y-intercept is beyond me. Oh, I just thought of that one. Okay? But here's what a y-intercept looks like. If I have a graph of a line, oops, I'll do it like that. Say the green line is my graph. The y-intercept would be the point at which the graph crosses the y-axis. Okay? It's the place where the graph crosses the y-axis. That's the y-intercept, or where it intercepts the y-axis. So again, you can tell that just from looking at the equation. Whatever this lone value is, that is where the graph crosses the y-axis.